Let's begin by determining the density of water. I have here a 100 ml graduated cylinder. We can determine its mass using a digital balance. And actually, one of the nice things about a digital balance is that we can tare it, which means that we set it to 0 with the mass on it. And now I can just add some water to that and determine its mass. And the mass that I have here is then 67 grams. So the mass is 67 grams. The volume that I have is 68 milliliters. And so the density is then 67 divided by 68 equals 0.99 grams per milliliter. So the density of water is 0.99 grams per milliliter. And students can take different volumes, more or less than what we have here, and calculate the density, and they will find that the density is approximately the same value every time. And density is thus one property of matter. Whether we have a small amount of water or a large amount of water, the density is the same. I have some methyl hydrate or methanol here, and again we'll tare the graduated cylinder. I'll pour a little bit of methanol into a beaker to make it easier to pour, and again we'll add it to the graduated cylinder and determine its mass. In this case, the mass is 49 grams, and the volume is 63 milliliters. 0.78 grams per milliliter. Now when you compare that number with water, that tells us then that we have less matter per unit volume. And so therefore, methanol is less dense than water. For safety reasons, it's best that the teacher do the methanol density rather than having all the students do it, because methanol, when it's spilled, can create vapors which may be hazardous to children. And so you don't want to have any methanol spilled in the classroom, but nevertheless it makes a great demonstration for the teacher, and it's important for students to realize that different liquids have different densities. And here they then calculate the density of two different liquids, water and methanol.